Hi guys, today I want you to be able to look at a table of data to determine whether that data is going to be linear or nonlinear. So if we have a picture to look at, okay, and we graph the dots and we see that they're more or less in a straight line, we can say, well, that data is linear. Okay, it's right in a nice straight line. But if our data is kind of curved or all over the place, then that's not linear, okay? And we can see that super easily from a picture. But if we're looking at a chart of data, okay, we don't have a picture to look at. So I'm going to give you strategies to determine if your data is linear or nonlinear by looking at patterns you see in the numbers, okay? Basically, what you're going to do is, if the numbers in the X column are counting by the same thing, could be ones, could be twos, but whatever it is, as long as it's the same number every time, and the number on the Y side is counting by the same number every time, then that's linear the easy way, okay? Because that means our data is consistent and counts by the same thing both sides every time. So let me do some more examples, okay? So this side 0 to 2 counts by 2, 2 to 4 counts by 2, 4 to 6 counts by 2, and 6 to 8 counts by 2. I'm going to caution you, check every level. Don't just say, okay, 0 to 2 counts by 2s, and then just put 2s down the side. You have to check every level. They're not all going to do that. You could get 2, 2, 2, and then a 7. Okay, be aware of that. Your data may not be as consistent as you think. All right, on the Y side, 10 to 14 counted by 4, 14 to 18 went up by 4, 18 to 22 went up by 4, and 22 to 26 went up by 4. So the X side went up by 2s, the Y side went up by 4s. This data is linear. All right, next, the 0 to 1, that went up by 1. 1 to 3, ooh, that went up by 2. 3 to 6, well, that went up by 3. And 6 to 10, well, that went up by 4. Hey, 1, 2, 3, 4 is a pattern. Well, that is a pattern, but it's kind of a coincidence. It's not a pattern that tells us anything. Okay? Remember, what we're looking for is the same number, different numbers. These are different numbers from each other. Okay? This is a 2. This is a 4. This is a 6. This is an 8. Hey, that's also a pattern. That's the even numbers. Well, that's interesting, but I'll tell you that that's not going to help you determine whether it's linear or nonlinear. In fact, just because number 2 is different than number 1, I can't say right now, well, they didn't count by the same thing every time, so it's not linear. Well, it still can be. I just have to do extra work to figure it out. Okay, so these numbers go across the bottom. What I have to do is set up divisions. Okay, basically I have to calculate the rate of change for every level. 1, 2, 3, and 4. And these are all the tops of our division problems. 2, 4, 6, 8. So we're going to set up these divisions. Okay, 2 over 1 is 2. 4 divided by 2 is 2, 6 divided by 3 is 2, and 8 divided by 4 is 2. Okay, these are all the same. That means it's linear. All it means when my data is not evenly spaced out, but it's still linear, is that my dots would not be the same distance together on the line. So if I look at this and I have like this dot is close to that dot, and that's even closer, but that's a little more spread out. That's really spread out. Oh, that's close. Spread out. Way spread out. Okay, if I were to graph all those points, they wouldn't count by the same number every time because they're not evenly spaced. But they're still linear. Okay? And this last one, 0 to 5, goes up by 5. 5 down to 1 is counting down by 4. Then 1 back up to 3 is up by 2. and 3 to 7 is up by 4. So that's not even a pattern. But remember, I told you the patterns are not, they don't mean anything. If you happen to get a pattern, it doesn't mean anything anyway. You know, the only thing that means something is the same number every time. Okay, this side, 3 to 13 is 10. 13 to 8 is negative 5. Okay, so I've got the jumps for each row. So again, I will make 1, 2, 3, 4 division problems. How do I know 4? Because I've got 4 little rainbows. Remember that the x's are my bottoms. So 5, negative 4, 2, and 4. My change in y are my tops. 10, negative 8, 4, and 8. And then I'm going to divide these. 10 divided by 5 is 2. Negative 8 over negative 4, also 2. 4 over 2, 2. 8 over 4, 2. These all came out the same, so this is linear. By the way, this is not intentional, that it's always 2 so far. That's not always going to happen. Okay? All right, so how do you tell if something is nonlinear? Well, the easiest version is you'll have one side that consistently counts by a number. It could be the x side, could be the y side. And then the other side, these will be all different. You could even have some of them the same, but if they're not all the same, then it doesn't count. Okay? All the same is what matters. All right. More nonlinear examples. Okay, so counting by 2, 2, 2, 2, 1, 2. Okay, so this side counts by the same number. It's counting by 2. This side counts by a pattern, but I will stress again, patterns don't matter. 1, 2, 3, 4. All that I need to know is that these numbers are all different. So this is non-linear. Next one. 1, 1, 1, 1, 1, 2. Oh, 8 to 13 is 5. Thought I would trick you again. Okay. Again, these counted by the same number. These are all different. So this is nonlinear. And my last example. 0 to 4 is 4. 4 to 9 is 5. That doesn't look like a 5. 9 to 16 is 7, and 16 to 25 is 9. No real pattern to that. Okay, 0 to 2. 2 to 3 is 1. 3 to 4 is 1. 4 to 5 is 1. Okay, so none of these are the same number. Some of these are the same number, but not all. Okay, so I'm going to make the division problems. Remember these, my x values go on the bottom. Change in x, change in y goes on top. So 4, 5, 7, 9, 2, 1, 1, 1. Okay, so 2/4 is 0.5. It's basically a half. Okay, 1/5 would be 0.2. 1/7 is 0.14, and I'm going to put ... That's a long decimal, and you know, knowing what the entire decimal is really not that important because I can already see different, different, different. This one's 0.1. All of these values are different. So that's nonlinear. Guys, even if some of those values were the same, if even one of them is different, then it's nonlinear. Okay. Now, some of your data is going to be presented horizontally instead of vertically. Okay? You don't do anything different except make your little rainbows go horizontal. So 1, 1, 1, 2, 2, 8 to 10 is, okay, so it's counting by the same thing on top and the same thing on the bottom. That's linear. 1, 1. Okay, it's counting by ones on top. Down by 2. Ooh, down by 1. Down by 4. So this is nonlinear because I have one row counting by the same thing and one row that's not counting by the same thing. Okay, let's say they're listed in coordinate pairs. Remember that the first number in all coordinate pairs is an x value, and the second number in all coordinate pairs is a y value. So 0 to 2, I counted by 2. 2 to 5, I counted by 3. 5 to 7, I counted by 2. And 7 to -2, I counted by -9. Okay, so I didn't count by numbers either time. I'm going to make fractions. 2 over 2, that equals 1. And -9 over 3, that equals -3. Well, these did not turn out the same. Nonlinear. Okay, 0 to 2, counted by 2. 2 to 4, counted by 2. Okay, so that's counting the same. 2 to 5, counted by 3. And 5 to 8, counted by 3. So this would be linear because it counted by the same thing on top and on bottom. Thank you very much for tuning in. See you next time.